Hi everybody and welcome. Today we're going to be talking about right triangle trigonometry. So your goal after watching these series of videos will be able to identify and solve for unknown angles using trigonometry and right triangles. So first things first, what is trigonometry? Definitely a big word here. So this is just actually a ratio of the lengths of two sides of a right triangle. So a couple things that are important to emphasize here when we're looking at this definition. The first thing is it does need to be a right triangle. So that is super, super important. This does not work for any triangle, only right triangles. Second thing is we're basically comparing two side lengths. So before we can jump into a whole lot with solving and doing all of that, the most common mistake with trigonometry is identifying the sides of a triangle. So a few things to start off with. We have a right triangle here, and they always give us some angle. Either they give us a measure of one, or you decide you're going to use the measure of that one. And based off of that, you need to determine what sides you're going to use. So again, to be clear, we're using this angle here. This is angle X. Now, a few things that will always hold true. Number one, we have that 90-degree angle in the bottom corner. We know that that is there. That's why we can do trigonometry. Second, the longest side is called the hypotenuse. And it's always the longest side, always the hypotenuse. And a way to double check if you're not sure a couple sides look similar to each other is just trace the 90-degree angle. Directly across from the 90-degree angle, we have the hypotenuse. So again, does not matter what the triangle looks like, what you're doing with it, if it's really narrow like this, or if it's super long the other way, or if it looks pretty equal, does not make a difference. Find your 90-degree angle, trace the side from across from it, and that is your hypotenuse. So longest side, always across from the 90-degree angle, hypotenuse. Second thing, very, very commonly mistaken here as well, is the adjacent side. Adjacent just means next to. So if we're looking at this angle right here, again, our angle that we highlighted, directly next to it, the angle is literally touching that side. That is your adjacent side. So because we're using that angle, the angle touches that side, it is adjacent. Let's say that we were using a different angle. If we're using this angle, the side I just labeled is no longer adjacent. It would be the side that is touching it. It would be that side would be the adjacent side. So let's go through a few more examples here. If we use this angle, the adjacent side to that angle is directly touching it. It is part of the angle, quite literally. The adjacent side is part of the angle. Let's do another one. Let's say we do it here this time. Again, the adjacent side is part of that angle. Next, if we go down here, again, the adjacent side is part of the angle. If it is not directly touching the angle, it is not adjacent. That leaves us with our last measure, which is the opposite side. So find the angle, trace completely across from it, you have your opposite side. The opposite side does not touch the angle in any way. It is not part of the angle. It is across the triangle from it. So again, not touching the angle in any way, across the triangle from it. Not touching the angle in any way, across the triangle from it. Not touching the angle in any way, across the triangle from it. The next set of questions are just dealing with identifying these three things. I know that this does not seem like a lot to do, but if we don't have the basics down, everything we do after it is going to be 100% wrong.